All right, let's talk SAT polynomials. You know that feeling, right? You see one of those long, crazy equations and your brain just freezes up. Well, you're in exactly the right spot. Today, we're going to crack the code on these things. We're going to turn that panic into pure confidence. Let's get into it. So, what even are these things? I love how our source material puts it. They're not just a jumble of math. Think of them as expressions with an attitude. Yeah, they've got a lot going on, multiple terms, different variables, and let's be honest, a lot of places where you can make a mistake. But that's exactly what we're here to fix. And this right here, this is the whole secret to the SAT. The test isn't trying to find out if you're the next Einstein. Nope. It's a test of one simple thing. Can you see a pattern instead of panicking? Can you stay cool and just apply a strategy you already know? That's it. And that's the exact mindset we're building today. Okay, first things first, we have to start with the foundation, the basic building blocks. These are the core rules of the game. And trust me, if you get these down, all those hard questions, they suddenly start looking a whole lot easier. So let's get a definition down. A polynomial, it's just an expression made up of a few simple ingredients. You've got your regular numbers, you've got variables like x, and you've got those variables raised to powers. The key thing to remember, the powers have to be whole numbers. No fractions, no square roots on the variables. That's it. Nice and clean. And this is a great way to see it visually. Think of it like a club with a strict dress code. On the left, you've got who's allowed in. Stuff like x squared plus 5x, or even just a simple number like 7. They're all good. But on the right, those are the rule breakers. Anything with division by x or a square root of x, nope, they're not getting in. The second you see one of those, you know you're not dealing with a polynomial. Okay, next piece of jargon. The degree. Sounds fancy, but it's super simple. It's just the biggest exponent you see on any variable. So why do we care? Well, this one little number is like a cheat code. It tells you so much about the polynomial, like its basic shape on a graph, what it does way off to the sides, and even how many answers you should be looking for. It's a hugely important clue. All right, listen up, because this is where so many people throw away easy points, combining like terms. The SAT loves to catch you rushing here. These aren't knowledge mistakes. The source calls them speed crimes, and that's perfect. You go too fast, you drop a negative sign, and poof, a point is gone. Seriously, slowing down for just a second here is the fastest way to lock in the right answer. And that idea of being careful, you're going to need it for what's next. Okay, let's get to the main event, the factoring playbook. This is the SAT's absolute favorite thing to test with polynomials, because it's all about finding the hidden structure inside an equation. You can think of these as the SAT's go-to party tricks, and they're totally predictable once you know what to look for. And here is the golden rule. The first thing you do every single time is ask, is there something all the terms have in common? It could be a number, it could be an x, whatever it is, pull it out front. This one step makes your life so much easier. Skipping it, probably the #1 unforced error people make. Okay. Now for the classic quadratic, the one you see all the time. It boils down to a simple two-question game. First, you look at that last number, the 10, and you ask, what two numbers multiply to make 10? Then, you look at the middle number, the 7, and ask, okay, out of those pairs, which one adds up to 7? In this case, it's 5 and 2. And boom, just like that, you've got your factors, x plus 5 and x plus 2. All right, lean in for this one. This next pattern is the SAT's sneaky favorite. They use it all the time. And once you learn to spot it, it's a massive shortcut. It's called the difference of squares. And here's the deal. Anytime you see something that's a perfect square minus another perfect square, an alarm bell should go off in your head. Ding, ding, ding. Whether it's x squared minus 9 or 4x squared minus 25, they all break down into that simple a minus b times a plus b pattern. Spotting this? It's a game changer. So, okay, great, we can factor stuff, but so what? Why does this even matter? Well, this is where we connect the dots. We're about to take that skill and use it to do what the SAT actually wants you to do, solve equations and interpret graphs. So here's the step-by-step process. The second you see a question, ask for the solutions or the roots or the zeros, and trust me, you will. Your brain needs to do one thing automatically. Step 1, no exceptions, set the whole thing equal to 0. After that, it's easy. You just use your factoring skills and then figure out what x value makes each little piece equal to 0. And this is how it all ties into the graphs. You don't have to be a human graphing calculator to figure this out. The degree gives you the basic shape. That first number, the leading coefficient, tells you if the graph's arms go up or down. And the factors, the things we just found, those are literally your x-intercepts. They tell you exactly where the graph hits the x-axis. Okay, we've got the math down. Now let's get into some next-level strategy. We're going to talk about the common traps the SAT loves to set for you and the ultimate secret weapon that you can and absolutely should use. This list right here, this is a checklist of high score killers. Missing that common factor at the beginning, accidentally dropping a negative sign, totally forgetting to set the equation to 0, or finding one answer and moving on when there were actually two. See the pattern here? Every single one of these is a mistake you make when you're rushing. The SAT is designed to punish speed, not a lack of smarts. But what if there was a way to sidestep almost all of those traps? A power-up that isn't just allowed on the new digital SAT, it's literally built right into the test. That tool is Desmos, the graphing calculator that's right there on your screen. Our source material calls it polynomial X-ray vision, and honestly, that's the perfect description. It lets you literally see the answer without having to fight through all the messy algebra. Let's be super clear about how powerful this is. You take the equation from the question, you type it into Desmos, and it instantly graphs it for you. Think about a problem where the answers are going to be ugly decimals. Factoring that would be a total nightmare, right? But with Desmos, you just look at the graph. The answers are the x-intercepts. You can even just click on them. It's your ultimate safety net. You can use it to double-check your work, or if you're really stuck, you can use it to just find the answer. Okay, so let's wrap this all up. At the end of the day, cracking these polynomial problems isn't about memorizing a ton of formulas. It's about changing how you look at them. It's a total mindset shift. And I think this quote just nails it. The source calls it obedient math. I love that. Once you know the rules of the game, once you can spot the patterns, these problems stop being intimidating. They become predictable. You're the one in control. You tell the polynomial what to do, not the other way around. So I'm going to leave you with this question. This whole approach, looking for a pattern instead of panicking, using a strategy instead of just guessing, that doesn't just work for polynomials. It works for the entire SAT. So think about it. What other hard problems are sitting there, just waiting for you to see the simple pattern hiding inside?